Audio Jungle.
Hello, I'm Mark from Diverse Dimensions, and what we're going to talk about today is a simple reverse engineering project, something pretty typical that we'll see on a daily basis. And once we capture our data, the next thing we're going to be investigating is the types of file formats that we're able to create and export to the downstream user. This is the little part we're going to be using. We'll be using a Faro Edge arm with a Faro blue light laser line scanner. There's basically two means of data capture that we use here at Diverse Dimensions. We use the laser scanner, and then we also use hard probe data. So let's go ahead and get started. And first thing we'll do is we'll talk about probing features. That's the simplest form for us to do any type of reverse engineering. What we do is we go ahead and we start looking for shapes. Like for instance, a plane. We'll probe a plane, and it's just creating a series of points with a probe. And we've just created a plane. So what we'll do is we'll go through and we'll measure all the discernible features in there, whether they're planes, circles, cylinders, cones, any type of feature that we can create. And then from there, those features can all be exported as a simple IGES file, and they can be imported into ProE or SolidWorks. So those simple files that we'll create from probe features can be exported out of our software, and you can import it into your CAD design program. And then from there you can trim, extrude, and create your project from there. The next means of data capture will be laser scanning. So let me turn my laser live here a moment, and we'll start to scan. And what we're creating here is actually hundreds of thousands of points, which will create a point cloud. So that's just a quick example of some laser scanning. So now we've created a point cloud, and from that point cloud we can actually go ahead and we can just export that data as either a text file or an IGES file. The problem with a point cloud is the data is rather immense, and not many software packages do a very good job of dealing with a point cloud data. Most of your CAD packages don't, although more and more are starting to come into plugins that can deal with point clouds. So you may want to investigate that on your end as to what works with your system. Our typical workflow is we'll take that point cloud, we'll clean it up, and we'll create what we call a polygonized mesh. And as we look at on the screen here, at the polygonized mesh we've created from this scan data, it looks rather smooth, but it's still not perfect in the CAD world as far as parametric. And really what it is we're at a point where we've just got a watertight STL file. Okay, with the STL file, you'll have your polygonized mesh, and several softwares can actually take your STL file, your polygonized mesh, and pull it in, and you can use it as a template to actually draw over, or you may be able to even cut cross sections through it to create an exportable IGES file, something that you might be able to extrude or grow in your software. The other form of a file that is very close to an STL in kind of the way it reacts and the way it's created is an OBJ file. That OBJ file is the one that we look at on the screen right here. It's a watertight file, and it's useful in the broadcast world as both something you can use for 3D rendering and 3D animation. And then of course we can just take the raw point cloud and export it too. Then you just have a series of points, and there's not too many software programs that deal real well with it, but that's the way it would look coming to you. And we can also take the probe features and just export those as an IGES file too, then that's something that can be brought into your CAD package, and you'll need to do your extrusions and trimming to turn that into a workable model for yourself. But in our software, typically the next thing we'll do is we'll create, from our STL file, we'll take that file and we'll create a NURB surface. And this NURB surface, now we have a file that can be actually exported as a step file, an IGES file, an X_T, and all those file formats are pretty broad in their ability to be imported into the CAD packages that are available today. This surface is somewhat toolable, but it's not parametric. Once we've gone from point cloud to STL to a NURB surface, which is basically a dumb NURB surface, would be to bring it to a fully parametric model. And a fully parametric model, now that is something that you're going to want to have if you're going to be cutting metal or steel. It's the cleanest of all file formats, and as you see on the screen, it's far smoother than our STL. If I turn the STL back on, we can take a quick look back at that, and you can see the difference in the two surfaces there. So that's kind of in a nutshell, the different types of deliverables that we're able to take once we capture the data, organize the data, and decide what type of file export we're going to do. All right, so let's take a look at our website once. And on our website, we've got all these different file formats downloaded. So if you go to our laser scanning reverse engineering tab, you'll see the download sample data. And the download sample data is the exact data that we actually captured today. It's of this part. So you should be able to see, your different types of files there, your OBJ, your probe features, your STLs, your point cloud, your IGES step as a dumb NURB surface, and also a step model as a parametric surface, or a toolable surface, I should say, and then an X_T as a different choice as a export. So thanks for watching and following along with our brief explanation as to the different types of file formats that we can deliver to you. Would love to hear from you about your current or future reverse engineering needs. Just give us a call or feel free to drop us an email. Thank you.